antigens and immunogens. Molecules which have the ability to bind with antibodies or T cell receptors are called antigens. Molecules which are able to induce immune response immediately are called immunogens. All immunogens are antigens, but not all antigens are immunogens. Haptens. These are low molecular weight compounds which are not immunogenic on their own, but when linked to a carrier molecule they become immunogenic. Examples are dinitrophenol and indole acetic acid. Hapten molecules, when bind to a carrier molecule, it becomes hapten carrier complex, and when an animal gets immunized with this hapten carrier complex, the antibodies that are harvested comprises anti-carrier antibody, anti-hapten carrier complex antibody and anti-hapten antibodies. Examples of carrier molecules: albumin or BSA, bovine serum albumin. Epitopes. Epitopes are the immunodominant areas on an antigen to which variable region of an antibody or TCR bind. There are multiple epitopes present on an antigen. The part of the antibody molecule which bind with the epitope is termed as paratope. Variable region of an antibody is specific to an epitope. Similarly, all antibodies produced by a single B cell are targeted to a particular epitope. Requirements for immunogenicity. First is foreignness. More the evolutionary distance, more will be the immunogenicity. Thus, according to this diagram, chimpanzee will have the least immunogenicity for a human, while hydra has the most immunogenicity. Genotype of the host. Difference in genetic composition will show variation in immune response from same antigen. Size, molecular weight and composition of antigen also affect the immunogenicity. Here in this diagram we can see that the immunogenicity increases from going amino acids to proteins. Like proteins are the highest immunogenic. Usually molecules less than 5 to 10 kilodalton are non-immunogenic. Hydrophobic and insoluble antigens are more immunogenic than hydrophilic or soluble antigens. Conformation of the molecule. Structure of a molecule can increase or decrease its immunogenic response. For example, the antigens that are good in native form, when their disulfide bonds are disturbed, their immunogenicity decreases. Mobility of a segment of antigen. This also may increase or decrease its immune response. Adjuvants. These are chemicals or compounds when given with an antigen increases the immune response against them by any of the following methods. They induce granuloma formation, they increase the persistence of an antigen, stimulates lymphocytes non-specifically and induce the co-stimulatory signaling. Examples are Freund's adjuvants, lectins, LPS, that is lipopolysaccharide, phytohemagglutinin and concanavalin A. Route of administration. Antigens can be administered either intraperitoneally, intradermally, intravenously, subcutaneously or by nasopharyngeal or oral methods. Example, when snake venom is administered orally, it is non-immunogenic, while intravenously it is immunogenic. Similarly, polio vaccine is orally immunogenic but intravenously is not. Forces binding antigens to antibodies. There are complementary interaction between antigens and antibodies. Similar to any enzyme, substrate, receptor, ligand and other molecules involving complementarity. Electrostatic forces. These are the attraction between oppositely charged ionic groups. Hydrogen bondings. These are reversible bonds between hydrophilic groups. Hydrophobic bonds. Like any oil droplet tend to become large drop in water, side chains of valine, leucine and phenylalanine tend to associate in aqueous environment. Over 50% of strength of antigen-antibody bond comes from hydrophobic bonds. Van der Waals forces. These are the main forces. These are interaction between the electrons of external orbits of two different macromolecules. Here, two terms can be discussed: affinity and avidity. Affinity is the strength of interaction of epitope and paratope. This defines how readily an antigen can bind with antibody. High affinity means slow dissociation of antigen, while low affinity means the easy dissociation. Avidity means overall strength of all antigen binding sites of antibody and a multivalent antigen interaction under the physiological condition. Please note that an interaction may have low affinity but high avidity.